Right, children. Now it's time to do the exercise. So remember, as I told you before, you have to do your exercise before I complete this. So after that, you can watch what I explain here and check whether your answers are correct. Okay, right. We are going to start with the exercise given in the textbook. We will read this. Question number 1, part 1. What is biomass? What is the meaning of biomass, children? Do you know what biomass is? Biomass is any kind of plant or animal matter that can be used as a fuel. Understand, children? So by burning these different types of plant and animal matter, we can obtain energy. So what is the meaning of biomass? We'll write now. Plant and animal materials that can be used as fuels. Are called biomass. Okay. Plant and animal materials that can be used as fuels are called biomass. Do you remember what are the examples for biomass? Firewood. Firewood is the most widely used biomass. What are the other examples, children? Sawdust, rice bran, they are also coming under biomass, right? What is the similarity between biomass and fossil fuel? Now we know what biomass is. Biomass means plant and animal materials that can be used as fuels. What is the meaning of fossil fuels? What is contained in fossil fuels, children? So fossil fuels are formed due to the when these plant and animal materials or the buried plant and animal materials, when they undergo different changes because of extreme temperatures and pressures present in different parts of the earth. So this happens over millions of years. So due to the changes take place in plant and animal materials or buried plants and animal materials over millions of years, fossil fuels are formed. Okay, children? So when it comes to fossil fuels are also made out of plant and animal materials. Even biomass is also made out of plant and animal materials. So what is the basic type of energy present in plant and animal materials, children? That is solar energy. So why do we say that the basic type of energy present in plant and animal materials is solar energy? That is because plants obtain energy in order to do photosynthesis by solar energy. Okay, children? So by using solar energy, plants can do photosynthesis. And earlier we learned that animals directly or indirectly depend on plants. Therefore, energy contained in animals also gained by plants. Plants gain their energy from the sun. So in that way, what is the similarity between biomass and fossil fuels? When we consider both biomass and fossil fuels contain solar energy as the basic stored energy. Okay, let's write that. Energy stored in biomass and fossil fuels is solar energy. Okay, children? Energy stored in biomass and fossil fuels is solar energy, or the basic type of energy, primary type of energy stored in biomass and fossil fuels is solar energy. That is the similarity between biomass and fossil fuels. Okay, children? Right. Question number 2. What are the energy sources suitable to generate electricity in Sri Lanka? Now, what are the different types of energy sources that we can use? We already use energy stored in water. So that is a suitable type of energy for Sri Lanka. That is because we have a lot of water bodies. We have tanks, waterfalls and other reservoirs likewise. Okay, children. So let's write energy stored in water. Stored in water. And we can use solar energy as well because Sri Lanka is located near the equator. Therefore, throughout the year, we get a lot of sunlight, right? Therefore, as the next energy source, we can use sun. We can use wind as well because it is a very good renewable energy source that we can obtain again and again. Wind. And also we can use biomass. In rural areas, people still use biomass, different types of biomass like firewood, sawdust, etc. Right? Biomass. Understand, children? Next one. What are the fossil fuels that are used in power stations in Sri Lanka? What are the fossil fuels? Fossil fuels that are used in power stations in Sri Lanka. So basically, we use energy stored in water to generate electricity. Those are known as hydropower plants. But energy stored in water is not coming under fossil fuels. What are the examples for fossil fuels? Coal is one example, diesel, petrol, those are the examples for fossil fuels. So in Sri Lanka, basically we use coal and diesel in order to generate electricity. Okay, children. So I already explained you in Norochole we have a coal power plant or thermal power plant. And we have a diesel power plants as well. Okay, children, in Kalanithissa we have a diesel power plant. So we will write what are the fossil fuels that are used in power stations in Sri Lanka. Basically we use hydropower, but here the question it asks fossil fuels. Okay. Coal, diesel. These are the examples for different types of fossil fuels that are used to generate power, to generate electricity. Okay? Right. Question number 3, part 1. Suggest some measures to minimize the energy consumption in your home. So we already discussed this as well. What are the ways that you can minimize the consumption of energy and thereby you can save energy? What are the methods, children? We can turn off the lights when we don't use them. We can turn off the fans when we don't use them. What are the other methods that we can use to minimize this energy consumption? So during the daytime, we can use the daylight or natural light instead of lighting electric bulbs. What are the other examples, children? Do you remember I explained that there are some electrical items or electrical equipment that consume a large amount of energy or electricity, like old televisions, old refrigerators, old computers, likewise. So you can get rid of those type of old equipment and you can switch to different other modern equipment that consume the minimum amount of energy. Okay, children. So we will write some of them. Turn off the fans, lights when not in use. Use natural light during the daytime. during the day. What else, children? How to save water, because water is also a certain type of energy source. How to save water? We can turn off the taps when while we are brushing our teeth or applying soap. Okay, children? Right. Keep the tap closed while brushing teeth. Right, children? Turn off the fans, lights when not in use. Use natural light during the day. And keep the taps closed while brushing teeth and applying soap. And for your fathers, while they are shaving, they can keep the taps closed. Okay, children? So there are many examples you can write under this. The next one. What are the energy sources that will be used to a large extent in the future? So in the future, what is going to happen? So the non-renewable energy resources are going to finish. That is because of increased consumption. So the energy sources that takes a long time to regenerate are known as non-renewable energy sources. Okay. So nowadays we use fossil fuels to run our vehicles, and we use fossil fuels to generate electricity. So in the future, what will happen? There will be no fossil fuels to use. Therefore, we will have to switch to alternative energy sources like renewable energy sources. Okay? So what are the energy sources that will be used to a large extent in the future? So definitely solar energy and wind. Those type of energy sources will be used in the future. We will write sun, wind, energy stored in water, energy stored in water. What else, children? You can even mention tidal waves and sea waves as well. Okay? Tidal waves and sea waves. Okay, children? Sun, wind, energy stored in water, tidal waves and sea waves, they all are considered as renewable energy sources, or the energy sources that we can obtain again and again. Okay, children? Right. So now we have completed the exercise given in the textbook. But I have another set of questions so that you all can practice what you have learned better by answering those questions as well. So we are going to do some additional exercises now. Okay. Exercise number 1. Underline the most correct answer. We will read them. An instance where energy is consumed is. An instance where energy is consumed, where we use energy. You all know that to do any work, to do any activity, we need to use energy. Without energy, we can't do any work. Right? So we will read them. Lifting a weight. So for lifting weights, we need energy. Without energy, can we lift weights? We cannot. Right? Jumping, playing. So all these activities, we need a lot of energy in order to engage in these type of activities. Okay, children? So what is the answer? Answer number 4, all the above. That is the answer. Lifting a weight, jumping and playing, all 3 instances need large amount of energy. Okay, children? So answer is all the above. Number 2. The main source of energy is. So we learned there are different types of energy sources. What are the examples? Sun, wind, energy stored in water, biomass, nuclear energy, likewise. So when you consider different types of energy sources, what is the main source of energy that gives us energy? That is sun. Okay, children, or solar energy. So sun, moon, water, electricity. The answer is sun. Okay. Number 3. Which of the following sources of energy gives thermal energy during combustion? What is the meaning of combustion? Combustion means burning something. So which of the following sources of energy gives thermal energy? Thermal energy means heat energy. Okay. We will go through this. Wind. Combustion doesn't take place in wind. Therefore, that is not the answer. Sun. Sun gives us heat energy. But this heat is produced by nuclear reactions, not by combustion. Okay, children? Fuel. So when it comes to fuel, by burning fuel, we can obtain heat energy. In order to obtain heat energy, we can burn fuel. Burning something means that is combustion, right? So fuel is the answer. Fourth one, nuclear power plants. Nuclear reactions take place. Energy or thermal energy is generated by nuclear reactions, not by combustion. Okay, children? So, answer is fuel. Which of the following source of energy gives thermal energy during combustion? Fuel. Right. Number 4. The natural source of energy that gives light energy and heat energy is the natural source of energy. Sun. Sun is the answer, but we'll go through the rest. Wind. Wind doesn't give heat energy or light energy, right? Nuclear power plants are not coming under natural source of energy because during nuclear reactions, we have to generate this one. Dynamo doesn't give light energy. When the parts of the dynamo work, those machine parts get heated up, but it does not give us light energy, okay? So dynamo can generate electrical energy. So the answer is the natural source of energy that gives light energy and heat energy is sun. Understand, children? Right. The next one. Right. Number 5. The main type of biomass that we use is, now you all know many examples for biomass, children. Firewood, coconut shells and sawdust, those type of examples we learned. Okay. So out of all these examples, what is the most widely used type of biomass, children? Solar heat is not coming under biomass. Wind is also not coming under biomass. Sawdust and firewood definitely coming under biomass, but out of these two, the most used biomass, the main type of biomass that we use is firewood. Right. Number 6. Coal, petroleum oil and petroleum gas are considered as coal, petroleum oil. What are the examples for, what are the substances contained in petroleum oil? Petrol, diesel containing petroleum oil and petroleum gas like LP gas. What are they, children? Now, coal, petroleum oil and petroleum gas are considered as, under which category all these three things are coming? That is under fossil fuels. Okay, children? Biofuels, nuclear fuels, biomass, fossil fuels. Answer is fossil fuels. Right. Number 7. The water level of the sea changes due to the effects of the sun and the moon. These changes can be used to produce. Now we learned that because of the gravitational force of the sun and the moon, sea water level changes. Sometimes the water level increases than the normal level and sometimes the water level reduces than the normal level. These instances are known as tidal waves, occurrence of tidal waves. Okay, children? So these changes can be used to produce, and we learned that tidal waves can be used to generate electricity, right? So these changes can be used to produce geothermal energy. No, geothermal energy is another type of energy source. Electricity, that answer is correct. Nuclear power and biogas, they are not the answers. Answer is electricity. Number 8. Which of the following ways of generating electricity leads to the highest environmental pollution? We will go through them. By burning fuel. I told you, when you burn fuel, that can be, now when it comes to different types of fuel, biomass is also a type of fuel. Okay? And fossil fuels are also coming under types of fuels. So when we burn any kind of fuel, carbon dioxide gets released to the environment. Especially when we burn fossil fuels, a lot of carbon dioxide gas and a lot of carbon particles, sulfur particles get added to the environment. Okay, they are harmful to the environment. So they cause environmental pollution. What about the others? By solar energy, by wind, by flowing water. Remember children, all these three instances when we generate electricity using these three energy sources, the environmental pollution is minimized. Understand children? So when you take these four examples, here, which of the following ways of generating electricity leads to the highest environmental pollution? Right? So by burning fuel, it will highly affect the environment. Okay? So answer is by burning fuel. Okay? Number 9. Energy is defined as. What is the definition of energy? What is the meaning of energy? Energy is the ability to do work. Okay? So energy is defined as power, work, movement. They are not the answers. The ability to do work. Okay? Energy is defined as the ability to do work. Number 10. The gas produced using rotten vegetables, kitchen waste, etc. Now, do you remember under biomass, I explained that things like vegetables, rotten vegetables, kitchen waste can be collected in a closed vessel, right? In a closed tank, in a sealed tank. You can put everything into a sealed tank, right? And then you can let it decay with the minimum amount of air present inside. Now, when the tank is sealed, only a very little amount of air is present. So, some microorganisms, some bacteria and fungi can act on these substances with these conditions. Okay, and these microorganisms can break down these substances like rotten vegetables and kitchen waste very slowly, and then a certain type of gas is released. This gas is known as biogas. So you can take out this gas and use it as a fuel. Understand children? So the gas produced using rotten vegetables, kitchen waste, these are coming under biomass. Okay, so what is the gas? Biogas. Liquid petroleum gas means LP gas. Liquid petroleum gas, here given LP gas. They're both the same. And hydrogen gas, they are not the answers. Okay, the answer is biogas. Right. Right. Number 11. The most widely used energy sources in the past were. In the past, about 200 years back, people did not have different types of machines. They did not have the technology, right? So basically they used solar energy and wind energy in order to get their work done, right children? So the most widely used energy sources in the past were sun and sea waves. In order to use sea waves to generate electricity, you need a good technology, right? Firewood and geothermal energy. Again, in order to use geothermal energy, you need special machines. So in the past, they did not have these type of machines, right? Sun and firewood. That is the answer. Sun, in order to dry things, in order to dry their clothes, dry their grains, they use sun. Another type of energy source that was used was wind. And apart from that, firewood was also used in order to cook food, in order to heat water. Okay, children? Wind and tidal waves. Again, wind is correct, But tidal waves, in order to use these tidal waves, you need special machines. Okay, so the answer is sun and firewood. Number 12. Select the correct statement. When the population grows, energy sources also increase. Is this correct, children? So when we consider about fossil fuels, when the population grows, population means the number of people. When the population grows, does this energy fuel also increases? No, it does not happen. Instead we consume these energy sources, okay? Energy sources shouldn't be used sustainably. Do you remember what is the meaning of sustainable use of energy sources? Sustainable use of energy sources means, children, while we are using it, we have to use them without wasting, so our future generations also can use them. Right? So energy sources should not be used sustainably. No, that is not correct. We have to. Energy sources should be used sustainably. Okay, so this is also not correct. Solar energy is running out. It's also not correct because the solar energy is a renewable energy source. Renewable energy sources means the type of energy sources that we can obtain again and again. So we are not running out of solar energy, right? So next one, by using energy sources without wasting, we can protect them for our future generations. This is correct. This is what we call sustainable use of energy sources, right? So answer number 4. Okay. Number 13. A country with a nuclear power plant. I explained you nuclear power plants, most of the time developed countries, they have these type of nuclear power plants, right? Because in order to build these type of nuclear power plants, we need a large capital. So our country we don't have, right? So a country with a nuclear power plant, Sri Lanka, Norway, Russia, Malaysia. Out of these countries, Russia is the answer, right? Russia is the answer. Right. Number 14. The largest hydropower plant in Sri Lanka is, we have a lot of hydropower plants in Sri Lanka. There are a number of hydropower plants. Renewable power plant, Rantambe, Victoria, Upper Kothmale, Lakshapana, these are the examples, right? So what is the largest hydropower plant? That is Victoria Power Plant. Kothmale, Victoria, Rantambe, Lakshapana. Answer number 2. Now, these type of questions are coming under general knowledge, children. Okay. So, as children who learn science, you have to read different articles, you have to read magazines, educational magazines. Okay. So, you can improve your knowledge by reading different articles. Okay, children. So, this is a type of general knowledge question. We'll move to the next. Number 15. Not a country rich in petroleum oil. Now I explained you what are the countries with petroleum oil. I told you that you can find information about these type of countries from the internet, from the atlas. Okay, so I explained that most of the time Middle East countries, they are rich in petroleum oil, right? So not a country rich in petroleum oil. Switzerland, Russia, Kuwait and United States. We learned that Russia, Kuwait and United States, they have petroleum oil with them, but Switzerland, they don't have. Right. Number 16. A radioactive element used in nuclear power plants is. Do you remember we learned that in order to generate nuclear energy in nuclear power plants, we use different substances called nuclear fuels, right? So these special type of nuclear fuels, they are known as radioactive elements. I explained to you that atoms of these different types of special elements, they behave in a different way. That is why we can use, because of this different behavior of these atoms, we can use these type of substances to generate nuclear power. These type of substances or these type of elements that behave in different way are known as radioactive elements. Okay, children? So a radioactive element used in nuclear power plants is, in order to generate nuclear energy, manganese, uranium, aluminium, nickel. I explained that a substance called uranium, an element called uranium is used in nuclear power plants. So answer is uranium. Number 17. A place where a wind power plant is located in Sri Lanka is. Now this is easy because we learned different examples, right? Badulla, Hunnasgiriya, Hambantota, Galle. What is the answer, children? Hambantota. Do you remember I explained that in Hambantota, Puttalam? And if you travel in Ambeville area, you will see these type of wind power plants too, right? Hambantota. 18. Not an example for biomass. Now, what is the meaning of biomass? Plant or animal materials that can be used as a fuel. Okay. So, not an example. Water is not coming under biomass, right? When you consider hay, rice bran and cow dung. Hay means dried up paddy leaves. And rice bran, cow dung. Cow dung can be used as a biomass. Dried cow dung, by burning dried cow dung, we can obtain heat energy. Okay, children? So, hay, rice bran and cow dung come in under biomass, but water is not a biomass. Right. Number 19. A country that uses nuclear power to generate electricity. How can we use nuclear power to generate electricity, children? Do you remember? I explained that in nuclear power plants, during nuclear reactions, a large amount of thermal energy or heat energy is generated. This heat energy can be used to produce steam. So how do we produce steam? In large boilers, we can heat a large amount of water at once using this large amount of heat energy released. So then what happens? Steam at high temperature and high pressure is generated. Understand? This heat, this pressure of this steam can be used to rotate turbines and thereby to generate electricity. Okay, children? So a country that uses nuclear power to generate electricity is Myanmar, Rwanda, France and Nepal. The answer is France. Okay, these are three other countries, they don't use nuclear power plants or nuclear power to generate electricity. Right. Number 20. The energy stored in water at a higher position is. Now, do you remember when we learn about hydropower plants? I explained that in a hydropower plant, the water tank or the reservoir is located at a higher position than that of the power plant, than that of the turbine. What is the reason? Because when we store this water at a higher position, it stores a certain type of energy called, what is the name? Potential energy. So if more potential energy is stored in water, when it flows down towards the turbine, it can gain more energy in order to rotate these turbines. Okay, children? So the energy stored in water at a higher position is kinetic energy. Kinetic energy is the type of energy contained in a moving object, right? Water energy, heat energy, answer is potential energy. Okay, I hope this part was clear. Now we have completed the additional exercise number 1. We are going to do the additional exercise 2. Right, exercise number 2, question number 1. Mention 4 tasks that we perform in our day-to-day life. What are the activities that we engage in our day-to-day life? There are a lot of activities, children. And we learn that to do these activities, we need energy, right? So shall we write some examples? Mention 4 tasks. So when you go to school, you will have to walk, right? Walking. And when you are in the classroom, sometimes you have to lift your desk and lift your chair, or you have to sometimes push your desk, okay? Pushing a desk. Pushing a desk. Lifting a chair. Lifting a chair. Right. Writing is also another type of task. Okay, it's also an activity that needs energy. We will write that as well. Writing. There are many activities that you engage in, even at home. Sometimes if you clean your house, sweeping or washing clothes, these are also coming under different types of tasks that we engage in. Okay, right. Number 2. How do we get energy for the work we do? How do we get energy, children? What do we have to do in order to get energy? Do you remember how our body can produce energy? We learned it in the first lesson under respiration. So what is respiration? Respiration means production of energy in your body by the food you eat reacting with the oxygen you inhale. Okay, children, so that whole process is coming under respiration. That is how our body generates energy or produces energy. So that energy produced by the body is used to engage in different tasks like this. Okay, children. So how do we get energy for the work we do? What do we have to do in order to get this energy? We have to eat food, right? So how do we get oxygen? By breathing in. That is something we automatically do without our knowledge. But in order to get energy, we have to eat food, right? So how do we get energy for the work we do? From food. From food. Okay? Right. Number 3. Additional exercise 3. Fill in the blanks. We will read this. Number 1. Is needed to do work. Now this is very easy. What do you need to do work? Energy. Energy. Okay. Number 2. Energy is defined as the ability to do, what is the answer? Work. The definition of energy is the ability to do work, right? Energy is defined as the ability to do work. And the next one. The wind propeller rotates using the energy of the wind. Do you remember we made a wind propeller, and when you run fast, the wind propeller also rotates faster because of the wind speed. Okay, children? So the wind propeller rotates using the energy of the wind. Number 4. Energy is used to cook food using a solar thermal stove. Do you remember the solar thermal stove? So in order to cook food using the solar thermal stove, what type of energy you need? You need solar energy, right? So if you consider, this is how the solar thermal stove, this is the shape, it is a concave shape, right? So this inside is, it is made out of a concave mirror, it's very shiny, therefore solar rays, sun's rays fall onto this concave mirror, right? The sunlight get reflected by this mirror and comes to one point. So because of the reflection of light and all the reflected light rays coming to this place, and this place has higher temperature. Therefore, if we place our vessel or the pot at this place, we can easily cook food or heat water, right? So what do we need in order to cook food using this type of solar thermal cooker? We need solar energy. Solar energy. Number 5. Energy is used to dry grains. That is again solar energy, right? Heat of the sun is used. So solar energy. Number 6. Things that provide energy are called. The things that gives us energy are known as, what is the name, children? Energy sources, right? Energy sources. Energy sources. So we learn different examples for energy sources. So we'll read this from the beginning. Energy is needed to do work. Energy is defined as the ability to do work. The wind propeller rotates using the energy of the wind. Solar energy is used to cook food using a solar thermal stove. Solar energy is used to dry grains. And things that provide energy are called energy sources. Okay? Right. Exercise number 4. Fill in the blanks of the table given below. So we have two sides. The first column, instance where energy is consumed, and the source of energy. I'm sure you remember we have done a similar activity when we were doing the lesson, right? So instance where energy is consumed and source of energy. So you have to fill in the blanks. So in the first one, this side is blank. Here source of energy is given sun. So an instance where solar energy, sun's energy is used. There are different instances. We can use the solar energy to dry clothes, to dry grains, to generate electricity, to heat water using the solar heaters. Okay, children? We will write source of energy sun, to dry clothes. Dry clothes. Right. Number 2. Running a vehicle. What do we need? What is the source of energy? What are the types of fuel that we use in order to, most of the time, to run vehicles? Petrol and diesel. So these are known as fossil fuels. Therefore, the source of energy is fossil fuels, right? So running a vehicle, fossil fuels. Number 3. This side is blank. Firewood or biomass. By burning firewood, we can get energy, heat energy, and we can use that heat energy to cook food and to heat water. Okay, children? So we will write that firewood, to cook food. To cook food. Number 4. Ironing clothes using electric iron. In order to operate electric iron, we need electricity. So what type of energy sources can be used to generate electricity? Basically in Sri Lanka, we use energy stored in water. Or we can use solar energy. Or we can even use wind energy. So here we have to write the source of energy. We will write the most common method in Sri Lanka. Energy stored in water. Energy stored in water. Okay. The last one. Heating water in a gas cooker. In order to heat water in a gas cooker, basically we use LP gas. So LP gas is coming under fossil fuels. So fossil fuel is the source of energy. Example is LP gas, right? So remember, this side you have to write source of energy. So here, what is the example? Fossil fuels. Fossil fuels. So if you want, within brackets, you can write LP gas, right? So to dry clothes, the source of energy, we need solar energy. We use solar energy. It's given by the sun, right? Running a vehicle, we use petrol and diesel basically. So it is the source of energy is fossil fuels. So to cook food, firewood or biomass. The type of or source of energy is biomass. Firewood is one example for biomass, right? Ironing clothes using electric iron, we need to generate electricity. Electricity is generated using different sources of energy like energy stored in water, solar energy, wind energy, okay? and heating water in a gas cooker, there we use LP gas or liquid petroleum gas. So LP gas is coming under fossil fuels. Okay? Right. Exercise number 5. First one. Where does the chemical energy in food come from? Remember, children. So when it comes to food, food gives us energy. What is the type of energy contained in food? Any type of food contain chemical energy. Okay. So if you consider our body as a machine, the fuel for our body is food. So any kind of fuel contains chemical energy. Okay, children, any kind of fuel contains chemical energy. So food also contains chemical energy. Okay. So where does the chemical energy in food come from? So where, from which place this food gets this chemical energy? So what is the place where food is produced in the first place, children? That is by plants. You all know that plants can produce their own food, and this is known as photosynthesis. So during photosynthesis, plants produce their own food. So this food also has chemical energy. So when the animals directly or indirectly depend on this food or on plants, this chemical energy goes to the animals. Okay. So that is how food contains chemical energy. Right, children? So where does the chemical energy in food come from? So basically food is produced in plants. So plants obtain this energy needed to produce food from what part, children? From the sun. Right? So by using solar energy, plants can produce their own food. Do you remember what are the factors affecting photosynthesis? Now I told you photosynthesis means the production of food in plants. So this process needs 4 factors. What are the 4 factors necessary for photosynthesis? Carbon dioxide gas, sunlight, chlorophyll present in plant leaves, so the green color pigment present, and soil water. Okay, so sunlight is one main factor affecting the photosynthesis. Understand, children? So this energy in order to produce food is taken from the sun. Okay, let's write. During the production of food, plants absorb solar energy and it is converted to chemical energy in food. Chemical energy in food. Okay, children. So what is the energy conversion takes place during photosynthesis or during production of food in plants? Plants absorb solar energy and it is converted to chemical energy in food. Okay, children. Number 2. What is the process by which food is produced in green plants? What is the name given for this process, children? Photosynthesis. Photosynthesis. What is the process by which food is produced in green plants? That is photosynthesis. Understand? Exercise number 6. Write 3 instances where solar energy is used in our day-to-day activities. So solar energy is used in different instances, right? So what are the instances that we used in our day-to-day activities, children? So we use solar energy to dry grains, to dry clothes, and to generate electricity. So when it comes to generating electricity, we don't do that as our day-to-day activity, right? So shall we write down what are the instances? To dry grains, to dry grains, to dry wet clothes. And do you remember we learned that to heat water using solar heaters? Do you remember that, children? In day-to-day life, we use that, right? To heat water using solar heaters. Okay, children. To dry grains, to dry wet clothes, to heat water using solar heaters. Okay. Number 2. What is the name given to the plant and animal material that can be used as fuel? Now we discussed about this one earlier. What is the name given? That is biomass. Biomass. Right? What is the name given to the plant and animal materials that can be used as fuel? Biomass. Give 3 examples of them. Means give 3 examples for biomass. Now we know many examples. We will write some of them. Coconut shells, firewood, and we can use sawdust. Right? Only 3 examples asked. Okay? Coconut shells, firewood, sawdust, hay, rice bran, dried cow dung. They all are coming under biomass. Right? Exercise number 7. Number 1. Write 2 fuels that can be used in soda stove. Do you remember we made a soda stove and I told you in addition to sawdust, we can even use rice bran, right? So rice bran and sawdust can be used in these type of soda stoves, okay? Sawdust, rice bran. Right, number 2. Write down an instance where each of the following biomass is used to obtain energy. Here this side biomass is given, this side instances where it is used to obtain energy, right? Firewood, we can burn firewood and heat energy is produced. This heat energy can be used to heat water and to cook food. We learned all these things. What about coconut shell charcoal? Now do you remember I told you in the past when electricity was not there, people used these special types of irons in order to iron clothes. So without electricity, how did they use these special types of irons? Using this coconut shell charcoal. Right, by burning coconut shells, you can obtain charcoal. So there's a place to insert this coconut shell charcoal. So with the heat of the coconut shell charcoal, the iron gets heated up and so you can use it to iron the clothes. Okay, children? We will write so firewood to cook food. To cook food. Right? Coconut shell charcoal to iron clothes. So in some rural areas without electricity, people still use these type of irons. Right, children? Firewood to cook food, coconut shell charcoal to iron clothes. Right? Exercise 8. Write 3 instances where the energy contained in wind is used. What are the instances where we use the wind in order to do our day-to-day activities? You can wind in order to generate electricity in wind power plants. That is one example. And we can use wind for sailing boats. What else? Farmers use this wind for winnowing paddy. Nowadays also farmers use this method. And in the past, people used the energy contained in the wind to grind grains and to pump water. Okay, children? And again, I explained you all that wind energy contained in the wind can be used to dry clothes efficiently, right? Basically, we can dry clothes using solar energy, but with the presence of the wind, we can dry clothes efficiently, right? So we will write to generate electricity. To generate electricity. To dry clothes efficiently. Farmers use it for winnowing paddy. Winnowing paddy. Okay, children? So you can write the other examples as well. So to generate electricity, to dry clothes efficiently, for winnowing paddy, right? Number 3. What is meant by high tides and low tides? Do you remember the differences between high tides and low tides, and what is the meaning of high tides and low tides? So do you remember we learned that because of the gravitational force, because of the effects of the sun and the moon, the seawater level changes. So sometimes the seawater level increases and sometimes it decreases. So the increase of the seawater level is known as high tides, occurrence of high tides, and reducing the seawater level than the normal levels is known as occurrence of low tides, right? So what is meant by high tides and low tides? We will write down. The seawater level changes due to the effects of the sun and the moon. The rise of the, or increase of, the rise of the seawater level is called high tides, and the fall of the, or reduction, fall of the seawater level is called low tides. Okay, children? The seawater level changes due to the effects of the sun and the moon. The rise of the seawater level is called high tides and the fall of the seawater level is called low tides. Okay? Additional exercise 9. Number 1. Explain what geothermal energy is. What is geothermal energy, children? Now, geothermal energy is a type of energy source. Do you remember how did we use this? How can we use this geothermal energy to generate electricity? So what is geothermal energy? So I explained that in some parts of the earth, the temperature is very high. Okay, in the inner earth crust, the temperature is very high in some parts. So if we can use this temperature to heat water, we can generate electricity. So how can we do that? Do you remember we learned that we can send pipes through these areas? I explained that these areas are known as hot rocks. So we can send pipes through these areas with high temperatures, and through the pipes from one side we can send water in. So when water flows through these high temperature areas, the water boils and steam is produced. So this steam at high pressure can be used to rotate turbines and thereby to generate electricity. Right, children? So explain what geothermal energy is. the high temperature zones present in the inner earth crust is known as geothermal energy. We will write the temperature of some regions of the inner earth crust is very high. This heat energy is called geothermal energy. Okay. The temperature of some regions of the inner earth crust is very high. This heat energy is called geothermal energy. So we can use this geothermal energy to generate electricity, right? Number 2. Some countries generate electricity using nuclear energy. How is electricity generated from nuclear energy, children? So how do we do this? Do you remember I explained that during nuclear reactions in nuclear power plants, a large amount of heat energy or thermal energy is released. So we can use this thermal energy to produce steam. So how do we produce steam? We can boil water in large boilers, right? So using the heat energy generated, we can boil water and we can produce steam. And this steam can be used to rotate steam turbines and thereby to generate electricity, right? Let's write thermal or heat energy. Thermal or heat energy produced during nuclear reactions. Nuclear reactions. Reactions can be used to produce steam. The steam can be used to rotate turbines and to generate electricity. Okay? Thermal or heat energy produced during nuclear reactions can be used to produce steam. The steam can be used to rotate turbines and to generate electricity. So I hope this is very clear now. We'll move to the next. Number 10. What is meant by sustainable use of energy sources? What is the meaning of sustainable use of energy sources, children? Now I explained this topic many times, right? Sustainable use of energy sources means the use of energy sources in a certain way as the future generations also can use them, right? So using energy sources without wasting, wisely we have to use them so our future generations also use them, right? Okay, let's write this one. Use of energy sources wisely without wasting, so that future generations can also use them. Okay. Use of energy sources wisely without wasting, so that use of energy sources wisely without wasting, so that future generations can also use them. Okay? Right. Next exercise. The diagram shows how a model of a turbine rotates using steam. Look at the diagram, children. Try to understand what is given here. So if you look at the diagram, you can see here heating. You have to heat water. This is the tin and water present. You can see this narrow tube and a turbine fixed, right? So when you heat water, what happens? Water boils. Water boils, and when the water boils, what is produced? Steam, right? So that steam can come through this narrow tube. Because the tube is narrow, steam coming out is at high pressure. Pressure is very high. So because of the high pressure of the steam coming out, you can see the turbine rotates. So the steam coming out of this narrow tube, the pressure is high. Because of the pressure, turbine rotates. Okay, children? Okay, we'll go to the questions given. When the turbine rotates, what is the energy contained in it? So when the turbine rotates, it means it is moving. So any type of moving objects contain, what is the type of energy? Kinetic energy, right? Let's write. So when the turbine rotates, what is the energy contained in it? Any type of moving objects contain kinetic energy. Kinetic energy. Right. How did the turbine get the energy it needed to rotate? How does this turbine rotate? Because of the high pressure of the steam coming out through the narrow tube. So how did this turbine get the energy it needed to rotate? So when we heat water, water boils and steam produces, right? So the steam coming out through the narrow tube has high pressure. Because of the pressure, turbine rotates, right? Let's write. When water is heated, steam produces. The steam comes out through the narrow tube. Narrow tube. Due to the high pressure of steam, the turbine rotates. The turbine rotates. Okay? How did the turbine get the energy it needed to rotate? When water is heated, steam produces. The steam comes out through the narrow tube. Due to the high pressure of the steam, the turbine rotates. It means in order to rotate this turbine, there should be a certain pressure to this steam. So that is why we have to use a narrow tube. Okay? Right, we'll move to the next. Write down the energy transformation that takes place in this process. So when this happens, what is the energy conversion or energy transformation that takes place? So you all can see you have to provide heat energy or thermal energy. So because of the heat energy or thermal energy, water boils and that steam produces, and because of the steam, the turbine rotates. So rotating means moving, it means kinetic energy. So what is the energy transformation? Thermal energy or heat energy to kinetic energy, right? Thermal energy to kinetic energy. Okay, children. Write down the energy transformation that takes place in this process. Thermal energy. Thermal energy means heat energy. Heat energy to kinetic energy. Right. Number 4. In a similar apparatus made by a student, even though the water heated up and the steam came out, the turbine did not rotate. What could be the reason for this? What does it say? Similar apparatus like this, water heats up and even steam comes out, but the turbine does not rotate. What could be the reason, children? There could be many reasons for this one. Let's say I told you in order to rotate this turbine, steam should be at high pressure, right? If the required pressure is not there, the required speed will not be there. Only if the pressure is there, it will come out at high speed as well. So if it can give the same speed to the turbine, turbine will rotate. If the pressure is not there, the speed will be low. So then what happens? Turbine will not rotate. So what could be the reason? I told you, in order to increase the pressure of this steam, you have to use a narrow tube, right? What will happen if the opening of the tube is wide? What will happen, children? The required pressure will not be given to the steam, so that the setup won't be able to rotate the turbine. What are the other instances? What could be the other reasons, children? So when it comes to the materials that you use to make this turbine, let's say that if the materials are too heavy, so even though the steam comes out at high pressure, if this turbine is too heavy, it will not rotate again. Okay, children? So those are the reasons. So if even though that water boils, water heats up, it boils and steam comes out, but still if the turbine does not rotate, those could be the reasons, right? Let's write. Let's write. The opening of the tube is too wide. Turbine being too heavy. Turbine being too heavy. The opening of the tube is too wide. Turbine being too heavy, right? These could be the reasons. Right. Number 5. The turbine can be rotated using wind too. Write 2 instances where this process is used. Now you all know that similar type of turbine can be used as wind turbines. Right now here the turbine is rotated using the steam. Similar instances, we can rotate turbines using a flow of water. We can rotate the turbines using wind too, right? So write two instances where this process is used. It means where we use wind turbines. What are the instances, children? You all know that we can use wind turbines in wind power plants in order to generate electricity, right? So wind turbines, when the wind turbine is connected to a dynamo, when the wind turbine rotates, what happens? The dynamo can generate electricity. What are the other instances that we can use these type of wind turbines, children? Wind turbines can be used to grind grains and also to pump water. People who in the past, they had used these type of methods to do their day-to-day activities, right? Let's write down. Write two instances. To generate electricity. To generate electricity. To grind grains. Windmills were used in the past. To grind grains. We ask only two, therefore we wrote two. To generate electricity, to grind grains. Okay. Number 6. Write down a material that you can use as blades when making a water turbine. Do you remember we made a water turbine using yogurt spoons? What did we use to make the turbine part? We used a cork stopper and we fixed some yogurt spoons, right? So let's write. Yogurt spoons. And even you can use metal blades, right? Okay.